A luxury sedan accelerates on a dynamometer to 145 miles per hour. Resting directly on the hood of the engine is a 5-story pyramid of 15 crystal glasses, filled to the brim with champagne. Despite the massive speed and the automatic transmission shifting through its gears, the glass pyramid remains perfectly still. Not a single drop of liquid spills. When this commercial aired in 1989, consumer advocates and the American public rejected it. Skeptics assumed the glasses were glued together, or that the entire stunt was a product of camera trickery. But the demonstration was real. It was eventually replicated live in front of a studio audience to prove that Toyota had successfully engineered an engine that produced zero perceptible vibration. The origin of that test dates back to August 1983, inside a highly confidential boardroom meeting in Japan. Toyota's chairman, Eiji Toyoda, issued a mandate to his executives that challenged the boundaries of automotive manufacturing. At the time, Toyota was synonymous with reliable, mass-market commuter vehicles. Toyota intended to leverage that reputation for quality to build a flagship luxury sedan that could directly challenge the Mercedes-Benz S-Class. This secret initiative was codenamed Project F1, or Flagship One. Toyota instituted 2 specific rules for the development teams. They could not use a single existing Toyota part, and there were absolutely no budget ceilings or development time limits. By removing every financial and temporal constraint, Toyota launched a blank check pursuit of absolute mechanical perfection. To execute this mandate, the company mobilized a dedicated industrial army of nearly 4,000 personnel. The operation required 60 designers, 1,400 elite engineers, and 2,300 manufacturing technicians. Rather than assembling a handful of test mules, this army built 450 functional platforms to evaluate every design and structural theory. These prototypes were subjected to 2.7 million miles of testing. Technicians drove them at maximum output across the German Autobahn and through the deserts of Arizona to expose any microscopic mechanical flaw. Toyota treated the development of a single model like a brute force engineering campaign, utilizing thousands of staff and millions of test miles to guarantee absolute durability in every climate on Earth. The mechanical heart of Project F1 and the key to the stability of those champagne glasses was the custom-developed 1UZ-FE V8 engine. Toyota spent $400 million and fabricated 973 distinct prototypes of this engine alone to achieve the exact performance metrics they demanded. Engineers arranged the block at a 90-degree V angle and secured the lower assembly with a rigid 6-bolt architecture to cancel vibrational forces. The steel crankshaft featured 8 counterweights to self-cancel secondary vibrations. Aerospace-grade tolerances reduced internal friction by 50%. To prevent any residual microvibrations from reaching the driver, the engine was mounted on revolutionary liquid-filled compound mounts that absorbed specific frequencies using hydraulic fluid. The 1UZ-FE mechanically isolated the cabin from the physical friction of combustion. It provided a level of refinement that rendered established European V8s unrefined by comparison. In January 1989, Toyota officially unveiled the finished vehicle at the Detroit Auto Show as the Lexus LS 400. It represented a direct entry into a market long dominated by the European elite. Beyond the engineering, Toyota delivered a financial blow that blindsided the industry. The LS 400 launched with a base price of just $35,000. This chart shows the severity of that pricing strategy. The $35,000 Lexus undercut the European competition entirely, representing practically half the cost of a Mercedes 300 SE. The market reaction was immediate. In just 1 year, Lexus sold over 42,000 units, instantly outselling the flagship models of Mercedes, BMW, and Jaguar in America. This combination of engineering quality and aggressive pricing broke the established European luxury monopoly, altering the luxury market for decades to come. Rival automakers rushed to purchase LS 400s from dealerships so they could tear them down and reverse engineer the Japanese threat. When Cadillac engineers disassembled the car, their final report was sobering. They concluded that the LS 400's microscopic tolerances physically could not be replicated using General Motors' existing assembly methods. BMW executives were so shocked by the quality-to-price ratio that they publicly accused Toyota of illegal dumping, alleging they were selling the cars below cost to bankrupt the competition. At Mercedes-Benz, technicians were forced to rush wildly expensive last-minute upgrades into their new S-Class to match the Lexus. The resulting budget overruns ultimately cost the Mercedes chief engineer his job. Project F1 proved that a blank check pursuit of precision could drag the global automotive industry to a higher standard, proving that engineering excellence is ultimately a matter of resources and intent.